Hello, my name is Dennis Raush, and I'm here to teach you about related rates. Related rates problems are problems involving finding a rate at which a quantity changes by relating that quantity to other quantities whose rates of changes we know. We use derivatives and given values to solve for this unknown value. There's a 5-step procedure which could be used to solve related rates problems. Step 1 is to identify the known variables and to draw a diagram if necessary. Step 2 is to construct an equation relating the quantities of what you know and the quantities of what you want to find. Step 3 is to differentiate both sides of this equation with respect to time. And step 4 is to substitute the known rates of change and the known quantities into the equation. Step 5 is to solve for the wanted rate of change. There are a couple mistakes which people do when solving related rates problems. The first one would be to plug in any constants before differentiating. The derivative of a constant is 0, and when you plug in constants before differentiating, you would get the wrong differential equation and get the wrong answer. Another mistake would be to use wrong units, and because of this, get the wrong answer. So let's do a couple problems. A conical paper cup 3 inches across the top and 4 inches deep is full of water. The cup springs a leak at the bottom and is losing water at the rate of 2 cubic inches per minute. How fast is the water level dropping at the instant when the water is exactly 3 inches deep? Express the answer in inches per minute. So step 1 is to identify the known variables and to draw a diagram. We know that the radius is 1.5 inches, the height is 4 inches, the rate of water level change is negative 2 inches cubed per minute, and we are looking for the rate of change of height when height is equal to 3 inches. Step 2 is to construct an equation relating the values. We know that the volume of a cone is V equals pi over 3 r squared times h. Since there's actually 3 variables here, we can simplify it by relating height and radius. And since r equals 3h over 8, this can be rewritten as v equals 3 pi over 64 times h cubed. Step 3 is to differentiate both sides of the equation. Here we're using both power rule and chain rule. Make sure you don't forget the chain rule because dh over dt is what we're looking for, and if you don't have it, you can't solve this equation. Step 4 is to substitute known values into our equation. We know dv over dt is negative 2 inches cubed per minute, and we know height is 4. So when we plug it in, we can solve for dh over dt. Step 5 is to solve for the wanted rate of change. We just have to simplify for dh over dt, and at the end we get negative 8 over 9 pi inches per minute. So the height is decreasing at 8 over 9 pi inches per minute when the water is 3 inches deep. Let's do another problem. A ladder 13 feet long is leaning against the side of the building. If the foot of the ladder is pulled away from the building at a constant rate of 2 inches per second, how fast is the angle formed by the ladder and the ground changing in radians per second at the instant when the top of the ladder is 12 feet above the ground? Step 1 is to identify the known variables and to draw a diagram. So we know the ladder length is 13 feet, and the rate of change is x, if x is the distance from the foot of the ladder to the building, is 2 inches per second. But since the ladder length is in feet, and we're looking in feet in general, we have to convert this into 1/6 feet per second. We're looking for d theta over dt when y is equal to 12 feet. Step 2 is to construct an equation relating the values. Here, cosine theta is equal to x over 13. Step 3 is to differentiate both sides of the equation. The derivative of cosine is negative sine, and so we have to use chain rule for both d theta over dt and dx over dt to get this equation. Step 4 is to substitute known values. When y is equal to 12, we can use Pythagorean theorem to get x is equal to 5, and we can use the definition of sine to get sine theta is equal to 12 over 13. When we plug this into the equation, we get negative 12 over 13 times d theta over dt is equal to 1/13 times 1 over 6. Step 5 is to solve for the wanted rate of change. So we just have to solve for d theta over dt, and we get negative 1 over 72 radians per second. So when the top of the ladder is 12 feet above the ground, the angle between the ladder and the ground is changing at negative 1 over 72 radians per second. I got all these problems for the second site here. I really recommend it. There's a lot more problems and very detailed solutions. And for more problems, you can do my worksheet, which is what Mrs. Nguyen probably posted online, or you could just search up related rates worksheets. Doing problems is the best practice for these. Thank you for listening, and I really hope you learned something today.